Hello, I'm Hashini, and in this video I'll be teaching you exponentials and logarithms from the P3 unit of Edexcel International A-Level. We will be revising this topic and at the end look at questions and how past papers examine your knowledge on this topic. So let's start with logarithms first. So what are logarithms? So you might already know about indices. So indices, what are indices? 2 to the power 3 equals 8. 5 to the power 2 equals 25. These are indices. You can see that there is this one large number here, which is called the base. This is called the base. And there's one tiny number on top, which is called the power. This is called the base and this is called the power. You can write this in a different form and that is called the log form. The same thing, the same expression, you can write it in log form. So this first one, let's change it in a log form. We can write it as log 2, 8 equals 3. We can write this as log 5, 25 equals 2. You can see, right, the pattern, how it goes. 2 here is the base here. So the base became the tiny number here and the power became the subject here. So 2 to the power 3 equals 8. This is one easy way to remember. So you start from 5 here. 5 to the power 2 equals 25. Go in a circle. So 5 to the power 2 equals 25. Let's do some other examples. A few of these. Let's say we have 2 to the power 8 equals 256. We can write this as log. So you can write 2 to the power 8 equals 256. 10 to the power 3 equals 1000. You can write it as log 10, 3 here and then 1000 here. Simple as that. Also, one other thing that you need to know is log 10 is special. Log base 10 is special other than log base 2 and stuff. So log base 10, we call it LG. We can write it as LG. So sometimes they might give it to you in the past papers as LG. And then you need to know that LG means log base 10. So this same thing you can write it as LG 1000. So LG 1000 is equal to 3. If they give it as LG, you must know that the base is always 10. Base is always 10. Now what is this other number that we get? Other letter, not the number, letter. E. What if we have something called e to the power a equals b? Now this e is not a normal letter like x and y, m and some etc. E is a special number, letter, that represents a special number called the Euler's constant. E is the Euler's constant. You don't have to know how this constant came to be, what is this constant. You don't have to know any of that for P3. If you want, you can search it up on the internet, but we're not going to focus on how the Euler's number, what is it and all of that. You just have to know that it's a very special number in logarithms and exponential functions. If we have e to the power a equals b, we can also write this as log e b equals a. Now this is very special. Why? Because log e is equal to n. Log e here is equal to something called ln. So ln b is equal to a. We can say like that. Log e is equal to ln, and ln b is equal to a according to this format. Okay. So these are the things that you need to know, the basic stuff, and the log rules. Let's look at the log rules now. So we have the log rules. What do we have in log rules? First one is log AB. I'm not going to write the base here. Base can be anything here. So log AB, we can write it as log A plus log B. You can see if it's multiplication, it's addition here. It becomes addition. I can also say if we have log A over B, A divided by B, this is equal to log A minus log B. It's the opposite. If it's multiplication, it becomes addition. If it's division, it becomes subtraction. If it's log A to the power n, I can write it as log A. This power n jumps to the front. This power n jumps to the front of log A. So n log A. Another law, another rule. Log x. What is this? If you have the same number here, the same tiny letter and the big letter, if they're both the same, we can say that this is equal to 1. If we have log 2, that is equal to 1. Log 10 equals 1. So if you have the same number, then it's equal to 1. Another rule, if we have log 1, log 1 is always equal to 0. Log 1 is always equal to 0. So these are the basic log rules, and there are two other rules. One other rule where we have a rule called the base changing rule, changing base. Changing base. And what is that rule? So if we have log AB, I can write it as log CB over log CA. Now this C can be any number, but these two numbers, they should be the same. If it's the large if the large letter or the number is B, we write it on top. The large letter and the number, we write it on top here in the numerator. The tiny one goes to the bottom, to the denominator. We'll do one example. Let's say we have log 57 equals, so log 57. How can we write this in this format? Pick any number you want. I'm going to pick 10. Log 10(7) over log 10(5). You see here? The larger number here goes to the numerator. The smaller number goes to the denominator. If we have let's take ln x. If you have ln x, how can we write it? What is ln x in the first place? ln x means log ex. Let me take a new page. I don't have space here. this is the same as log ex, right? So how can we write this as? We can write this as log 10x and log 10e. So we can write it like that. Okay, let's look at some questions. So you have to solve for x here. Log x 12 equals 10. You have to find x in the exact form. They're asking your answer in the exact form. So how can we solve this? I'll rewrite this. Log x 12 equals 10. By applying what we learned previously, we can say that x to the power 10 equals 12. Go in this cycle format. X to the power 10 equals 12. See, easy as that. Now, you have to be very careful here because they're asking your answer in the exact form. You can solve it by doing x equals the tiny 10 and the root 12 in the calculator, but if you do this, you are going to get a decimal answer. You are going to get a decimal answer. There's no way that you're going to get a third answer by doing that. So exact form means you have to get your answer without decimals. So how can you solve this to get your answer in the exact form? One way of doing this, now there are two different ways that you can try. One way of doing this is multiply this part in a way to remove that 10. So what is the way to remove that 10? You can multiply x to the power 10 by raising it to the power 1 over 10. So if you raise it to the power 1 over 10 here, you have to raise the 12 also to the power 1 over 10. Now, so you can if you expand this, you get 10 times 1 over 10 equals 12 to the power 10. These will cancel and you are going to get x equals 12 to the power 10. 12 to the power 1 over 10. Yeah. So this is your answer. Now, if you knew already that cube root x is equal to x to the power 1 over 3, then you wouldn't have to, I'm just giving this as an example. So if you knew this format, you wouldn't have to do these things. You wouldn't have to do these. So you know that x to the power 10 is equal to 12. Now this is our question, x to the power 10 equals 12. So you will know to write it as tiny root 10 over 12. Tiny root 10 root 12. Then x equals 12 to the power 1 over 10. You would be able to convert this to this. So if you knew it already, you wouldn't have to go doing these ones again. Another way of doing these types of questions is if you have log x 12 equals 10, you can multiply, you can try to make both sides have a log x. Now what I mean is like this. You can say log x 12 is equal to 10 multiplied by 1. Same thing. 10 multiplied by 1 is 10. Now this 1, I can write it as log x x. I wrote this 1 in the form log xx. So now you can see that the log x from this side gets cancelled with the log x here. But let's continue. Log x 12 equals, I can take this 10 up here. That's something I gave it in the log rules. So log x, the 10 became the power of x here. You can see that the log x is in both sides, so you can cancel it and equate this 12 to this x to the power 10. This 12 will equal to the x to the power 10 here. Why? What is the reason? Because it's the same log x in both sides. So 12 equals x to the power 10. And so you can continue what we did here. So multiplying x to the power 10 by 1 over 10. And this also to the power 1 over 10. So you have 12 1 over 10 equals x. So that's our first question. Let's go to the second question. Log x 10 equals log 5 2. How can you solve this? So let's write it down again. I'm going to copy paste it. Now you can write this, you can take this one as one answer. So you can write x to the power log 5 2 equals 10. X to the power log 5 2 equals 10. You can write it like that. Then what can we do? Now I told you in the previous question where we can multiply this by 1 over the power to cancel the power. So let's do that. X to the power log 5 2, I can multiply it 1 over log 5 2 equals, if I do that here, I have to do the same thing to the other side. So 1 over log 5 2. Now you can see that these two gets cancelled. So we are left with x equals 10 to the power 1 over log 5 2. Let's go to the next question. Log 2 5 plus log 2 x equals 7. We can say, I'll write it again, log 2 5 plus log 2x equals 7. This is, you can see that we have the same tiny number here, 2 and 2. So what does that mean? If it's addition, it's multiplication. If it's subtraction, it's division. We learned that in the log rules. So log 2 5x equals 7. I multiplied the 5 and x here. Now I can write this as 2 to the power 7 equals 5x, and x equals 2 to the power 7 divided by 5. So you can even simplify it saying 128 over 5. So that is this question. Let's go to the next one. We have log 5x minus log 5 3 equals 4. You can see it's the same base. What can we do? And you can see that it's subtraction, so it's division. So log 5x over 3 equals 4. You can say 5 to the power 4 equals x over 3. 5 to the power 4 equals x over 3. And you can say x equals 3 times 5 to the power 4, which is 1875. This is our example 4. Okay, now how about if we draw the graphs y equals e to the power x and y equals ln x? What will they look like? So let's start with y equals e to the power x. Now you have already done this in AS. So let's just find the coordinates first. I'll take this color. Yeah. So let's find what it is when x equals 0. Find the coordinate when x equals 0. So when x equals 0, we have y equals e to the power 0, which is equal to 1. Now let's find out what will happen if x is going to be infinity. When x tends to infinity, y is equal to e to the power infinity. This is plus infinity, okay? So when it's a large number, when x is a large number, e to the power large number will give us a large number, and I'm going to take it as infinity. What if x becomes minus infinity? Then y is going to be e to the power minus infinity, and that is going to give us a value 1 over e to the power infinity. So you can see e to the power infinity, we got it as a very large number here. E to the power infinity is a very large number here. So 1 over a very large number is 1 over infinity, and that is equal to 0. So we know these things. So let's plot the graph. So here we have the y-axis, and then we have the x-axis, y, x. So what do we have here? We know that when x is minus infinity, when x is over here, the y value is almost 0. Y value is almost 0. When x becomes minus infinity, y becomes 0. And when x is plus infinity, that means when x becomes a very large number, y becomes a very large number. That means y is going to be over here. When x is a very large number, y is going to be a very large number. And when x is a very large minus number, y becomes almost 0. So you can see the graph will go like that. Okay? And when x is 0, the graph cuts the y-axis at 1. So our graph looks like this. So where at this point is getting close to 0, but never reaches 0. So we call this point minus infinity, comma 0. And this point right here is going to be plus infinity, this coordinate. And this is going to be 0, comma 1. This is our y equals e to the power x graph. I'll repeat again. We found when x equals 0, how much was y? And y became 1. Because e to the power 0 is, anything to the power 0 is always 1. We found out the two coordinates when x equals infinity and negative infinity. So when x is plus infinity, e to the power infinity, that is equal to a very large number. You can input into the calculator e to the power a very large number, 99918, some huge number, and it will give you a large number. Then if you take minus infinity, e to the power minus infinity, you can write it as 1 over e to the power infinity. This minus, it goes to the denominator and it will become positive. And you know e to the power infinity is a very large number from the previous one, right? It's a very large number. So that means it is almost infinity. So 1 over infinity will give us 0. So that's how I got these coordinates to plot this exponential function, this e to the power x curve. Let's look at y equals ln x. I'll get this a little smaller. Y equals ln x. So I'll write it in orange. Yeah. When x equals 0, how much is y? When x equals 0, you're not going to get a y value. You're going to get y as a math error. You wouldn't get a number. So what are we going to do? We can't take 0, right? So because of that, if you can't input 0, we'll take a number that is close to 0, which is about x equals 0.00001, something like that. When you input a very small number to x, you're going to get, so y equals ln, the very small number, and that will be equal to a very large negative number. So I can say that it is going to be a negative infinity. Alright, negative infinity. So I can say y is equal to negative infinity. When x is 0, y is equal to negative infinity. Let me highlight that. When x equals 0, I'll take another color, that was ugly. Yeah, x equals 0, y is negative infinity. Let's pick another coordinate. What happens when x equals 1? When x equals 1, y is equal to ln 1, and that is equal to 0. Now you might think, why did you input x equals 1? So because of that, I'm just going to erase it. How did you know to put x equals 1? How did you know it's not x equals 2? You might get tons of questions like that and get confused. So let's start with, let's say, what had happened when y equals 0. So 0 equals ln x. How do we remove? So yeah, 0 equals log ex, we know that. Then x is equal to e to the power 0, so x is equal to 1. We can say that. So when y equals 0, x equals 1. That is our other coordinate. We took when x equals a very small number. Let's take what happens if x equals a very large number. For example, when x equals infinity, what happens? When x tends to infinity, y equals ln infinity. And that is also going to be a very large number. That is also going to be infinity. So we can draw a graph. So we have the y-axis here. Oh, I'm writing x here. Yeah. So y-axis. And we have x here. Now let's see our points. I'm going to highlight this. What do we have here? When x is 0, y is negative infinity. Where is x 0? X is 0 in this line. Y is negative infinity means it is down there, somewhere here. right? X equals 0 line is here, y equals negative infinity is here. Then what else will we have? When x equals a very small number, oh yeah, that is what we got now. So when y equals 0, what is it? Y equals 0 is this line right here. When y equals 0, we saw that x equals 1. Oh, it cuts the axis at this point. So here we go like this, and we came here. And then we know when x is infinity, y is infinity. X is infinity, y is infinity. So our graph will go like that. So let's draw that curve. Nice. So this point is going to be 0, negative infinity, and this is 1, 0, and this is positive infinity, infinity. These are the two graphs that we have. Y equals EX curve, this one, and ln x. What if we draw both of these curves together, like in the same axis? How will it look like? Now I know my ones, yeah, I will just draw it. So if we draw them on the same axis, they are going to be mirror images. What are mirror images? I'll show you. So this is the y-axis, this is the x-axis. We are going to have a line here. This is the y equals x axis here, y equals x. Y equals e to the power x is going to be like this. And y equals ln x will be like this. They are going to be both similar, and you can see both sides are symmetrical. This side is symmetrical to that side. So that is what we call as mirror images. If you keep a mirror here, it's going to be the mirror image in these sides. So this line is the y equals e to the power x curve, and this is the y equals ln x curve. Okay, I hope these things are clear. Yeah. So let's go to a question. Rate of temperature rise theta varies with the time t as shown below. Theta equals pt to the power q when ln theta is ln theta versus, sorry, it should be vs. ln t graph drawn. It passes through 0.8, 10 and 1.2, 30. Find p and q. So you need to find p and q. So let's start with this equation. Theta equals pt to the power q. They have given us these 2 points, right? So passes through these 2 points. So that means we are able to find the gradient of this curve. And we also have the intercept, the y-intercepts. So there should be something that we can do with the equation of the line, equation of the graph. So we'll turn this into the equation of the graph, ln theta versus ln t, right? So let's find them out. We can put both sides ln. So ln p times t to the power q. and ln theta. Now also one thing, ln and logarithm rules, they are the same, like they are very similar to each other. So if you have a multiplication here, that means you can write them as an addition, ln p plus ln t to the power q. So we have ln theta equals ln p. You know that from the log rules that if you have a power like this, you can bring the power to the front. So q ln t. Now we can rewrite this. Now what are they saying here? ln theta versus ln t. ln t is here, ln theta is here. If I rearrange this, I can bring this here and bring this here and show you how it goes. So this is the y coordinate. We can have this as the y coordinate. And we can have this, so this is the x coordinate. Then we can have this as the gradient m. This is going to be the intercept ln p plus c. You can see that it is a straight line now. mx plus c, y equals mx plus c curve. So q is the gradient, right? So let's find the gradient. You have these 2 points right here, so we can find the gradient. M is equal to y2 minus y1 over x2 minus x1. So m is equal to 30 minus 10 over 1.2 minus 0.8. When you input this into the calculator, you should be getting the answer as 50. M equals 50. So gradient is 50 means, what is the gradient? Q. So Q is equal to 50. Okay, now we found Q. And we also know that this is the intercept, right? So we can rewrite this equation like this. So we can write y equals 50x plus c. And we can input one of these coordinates here and find c value. Let's just pick one coordinate, this or this. Let's go with this, 0.8, 10. You can pick the other one if you want. So our coordinate that we picked was 0.8, 0.8, 10. Y is 10, 50, x is 0.8 plus c. Now if you solve this, you're going to get the c value as minus 30. What does that mean? The ln p is equal to minus 30. Now let's find p. How do you find p? You can write ln as log ep is equal to minus 30. We can write e to the power minus 30 equals p. Okay, so p is equal to how much? E to the power minus 30. Did we find all the letters? So they are asking for p and q. So we found p and q, yes. Q was equal to 50 from here, and p is equal to, we found it right here, e to the power minus 30. Therefore, p equals e to the power minus 30 and q equals 50. These are the answers. I hope it's clear. Let's go to the next question, the last one. Charge q stored in capacitor varying with time t is given by q equals q naught e to the power minus lambda t. The graph L and Q versus t. L and Q versus t. Now we don't have a graph like this, so we have to convert this equation into the graph equation. So let's do that. So the passes through this point and this point. Find the values of q theta, q naught and lambda. So the same type of question like before. So let's write it down. Q equals q naught e to the power minus lambda t. Let's change the format. So we can write ln in both sides. Ln q equals ln q e theta e to the power minus lambda t. What did we learn in log rules? Now here there's a multiplication, right? So it is like this, right? Okay. So now you can see how we put ln in both sides. This was 1, this was 1. So you put ln in both the sides. So according to log rules, you can, if it's a multiplication, you can write it in the form of addition. So ln q naught plus ln e to the power minus lambda t. So ln q is equal to ln q naught. You know that the power can jump to the front. So minus lambda t ln e. I'll just erase this plus because there's a minus there. Okay, now another thing that you need to know is ln e is equal to 1. Okay, new thing. Ln e is equal to 1. So our graph will look like this. ln q is equal to ln q naught minus lambda t. If I rearrange this, minus lambda t plus ln q, because they say the graph, but what is the graph that they have drawn? ln q versus t. So here we have ln q versus t. So this is the y-axis, this is the y. Then we have this as the x, and then we have this as the gradient, and we have the ln q right here as the intercept plus c. This is our curve, the line. Now you can see that, oops, I wrote x here, it should be m. So you can see that the m is equal to minus lambda, the gradient is minus lambda, and they have given us 2 points, so which means we can find the gradient. Let's find the gradient quickly. M is equal to y2 minus y1 over x2 minus x1. So let's pick 9.6 minus 4.8 over 0.75 minus 0.5. when you solve this, you should be getting minus 19.2, which means lambda let me double check this answer to be sure if it's actually. So 9.6 minus 4.8 over 0.75 minus 0.5. It is actually 19.2, not minus 19.2. It's plus 19.2. So you can see that the negative lambda minus lambda is equal to 19.2, which means lambda will be equal to minus 19.2. Okay. Again, this one is equal, minus lambda is equal to the m plus m. You found m, so you input the value of minus lambda here and you multiply this entire thing by minus. So you get lambda as positive and this is minus 19.2. Now you have lambda. They say find q naught and lambda. We found lambda, we need q naught. What can we do? We know that now using this y equals lambda is minus 19.2 and x plus c. Just pick one coordinate from here. Let's pick this. This is the coordinate that we picked. This is the x, this is the y. So y is 4.8 minus 19.2, x is 0.5 plus c. So c is equal to, when you calculate, you should be getting minus 4.8. So what is c now? C is ln q naught equals c. They're asking for q naught. So we can't keep it in the form of ln. What is ln? ln is log e. So q naught equals c. So e to the power. So we know c is equal to minus 4.8. So e to the power minus 4.8 is equal to q naught. So we found the two values. So q naught is equal to e to the power minus 4.8 and lambda is equal to minus 19.2. Okay. So I hope this question was clear. So we did two questions now.